This video will definitely be shorter than the last one, but I want to point something out before we get going on these, because when you do half angles, because of the formulas involved in half angles and sine and cosine, tangents not so, but sine and cosine, you have to figure out, is it positive or negative? Okay, so the way to do that, first, I'm going to go through every one of these, and let's just state up front, is the answer going to be positive? Is it going to be negative? Because this is where, these are not hard to figure out. The ones with triangles are a little bit of a challenge to figure out. So if I'm going to find sine of 22 degrees, this is quadrant 1, the answer is positive. So when I go to take a square root, it's going to be positive. This one, sum and difference, even though it's the sum or difference of 75, 75 is in quadrant 1, so I know it's positive. 157 is in the second quadrant, and it's cosine, so it's going to be a negative answer. 7 pi over 12. 7/12, that's a little more than halfway. That puts me in quadrant 2. It's a little more than halfway to pi. Okay? Pi, remember, pi is located right here, so 7/12 is somewhere in here. It's the second quadrant. Sine in the second quadrant is positive. 5/8. 5/8 is a little more than half, because 4/8 would be a half. That's also going to be quadrant 2. So if this is in quadrant 2 somewhere, cosine is going to be negative. Tangent for these two, well, we'll just have to wait and see how it is, because I would have to find a common denominator to know where this is going to be, and I don't want to go there yet. But that tells you real quick, for the most part, how to figure out if these are positive or negative when we get our answers. Now, going back to the first one, sine, here it is right here, sine of a over 2. So I can't do this just as sine of 22.5 over 2, because 22.5 is not on the unit circle. Okay? And it seems my camera has froze. There it is. It's not on the unit circle, so 22.5 is not helpful. But I'm trying to use half angle. So if I double this number, I would have sine of 45 over 2. Now, isn't 45 over 2 equal to 22.5? Yes. So what goes in here for this formula, the cosine of what I'm taking now is 45 over 2. So cosine of A, it's cosine of 45. So we write this as 1 minus cosine 45 over 2. Okay? 1 minus cosine of 45 over 2. Now, I don't take cosine of 45 and go, oh, here's cosine of 45. It's cosine sine. Remember, cosine sine. So it's the square root of 2 over 2. This does not become cosine of square root of 2 over 2. It actually is the square root of 2 over 2. 1 minus root 2 over 2, all over 2. Now I've got to find a common denominator here so that I can combine these two. Well, that's going to be 2 over 2. So this gives me the root, and remember this was positive, so I don't have to write anything else. 2 minus root 2 over 2, all over 2. All of this is under the square root, every last bit of it, because the original had a square root of 2 on the bottom that was under the root. Okay? Now that I've done that, I can do one of two things. I can multiply by a big 2 over 2, or cancel that and that becomes a 4, or I can say, oh, I want to keep, change, flip. Put this over 1, and I would say times 1/2, and it would get rid of this as well. Either way, I'm still under the radical. All right? I've got to keep pointing that out because you guys drop these radicals. All right, so this just becomes 2 minus the root 2 all over 4. Now I've got this fraction under the radical that is a problem, and I've got to split it. It becomes the square root of 2 minus the root of 2 all over the root of 4, which is, and I'm going to get rid of this because I don't need it now. We've already figured out positive, negative, which is the square root of 2 minus the root of 2. That is a minus sign. Now it looks like a plus. Let's fix that. I set it and wrote it sideways, kind of crooked. All over 2. That double root cannot be reduced, and that double root is why using the sine of a over 2, cosine of a over 2, using this is a horrible idea. Do not do it when you're given numbers like this and you're using the unit circle. Don't do it, okay? Sum and difference, okay? So when I see sum and difference, that means I've got to add to get this or subtract. So anything on the unit circle that will add up to 75. 30 and 45 are really easy to use. Since I am not doing the tangent of 30, I don't like tangent 30. Tangent 30 is mean, and we'll talk about that in a minute when we come to it. But I can use 30 and 45. 30 plus 45. So that's what I'm going to do is take cosine of 30 plus 45, and the cosine for addition means cosine, cosine minus sine, sine. Okay? That's what I'm going to have. Pause this when you need it, because I know I'm trying to go fast. So cosine 30 cosine 45 minus sine 30 cosine 45. Okay? So now I'm going to go in, I'm going to find these values. Cosine of 30, this is cosine, sine, I got square root of 3 over 2. It's not the cosine of square root of 3 over 2. It is the value of that. Cosine of 45 is square root 2 over 2. Sine of 30 is 1/2. Cosine of 45, because everything with a 45 except for tangent is square root of 2 over 2. All right, so I've got these multiplied. And guys, when you multiply two roots, it becomes the root of 6 over 4 minus the root of 2 over 4. 2 times 2 is 4. Okay? When these denominators match, we can combine what's on top, but these roots do not combine. It's just the root of 6 minus the root of 2 all over 4. Those of you trying to add those together, you don't know your roots. The rules for your roots, excuse me. All right, so you've got to know how to work with radicals, guys. All right, on this last one, we're doing half angle again. Back to half angle, and I'm doing cosine half angle. It's this one right here, and I determined that it's a negative to begin with. So it's negative root 1 plus cosine of something all over 2. Now this one, I need to double it to make it a half, because it needs to be written as cosine of 1/2 of something. So if I double this angle, I'm at 315. Half of 315, right? All right, so half of 315, the 315 becomes my theta, and this becomes 315. So I'm going to set this aside because I don't need it. What I do need is I need to know what cosine of 315 is. Cosine of 315, cosine sine, is positive root 2 over 2. Negative 1 plus root 2 over 2 all over 2. This becomes, this is a 2 over 2, negative, and I'm slowly losing my pencil, there we go, 2 plus the root of 2 over 2 over 2. Since on this first one over here, I simplified the way I did with keep, change, flip, I'm going to show you this one. There is another way you can do this. If I multiply this is my big fraction, by a big fraction of 2 over 2, this 2 cancels with that. This 2 down here becomes 4. So this is negative root, this is just going to be 2 plus the root of 2 all over 4. And this is where it splits on the top, 2 plus the root of 2 over the root of 4, which is equal to the negative 2 plus the root of 2 all over 2. Okay, so that square root has to get off the bottom. All right, sine of pi over 12, and these still are a source of pain for you all. And I've done these several times. I will keep doing them. I can tell you that the answer is going to come out positive. So I know that when I do the half angle, it's going to be a positive, and I'm going to write positive to begin with right here, just so you know. It's going to be 1 minus cosine of something, I don't know yet, all over 2. So in this one, this is where we want to think of all the things that go into 12. 3, you can change 7 pi over 12 to a degree if you prefer. 3, oh, I need a 2, 3, 4, 6, 8, 9, 10, ... There's a lot. I can add or subtract. I'm doing half angle. I just lost my mind. Just kidding. That means I have to take half this angle. And one of my kids came up to me and said, Miss Butel, can we just do half and take half of this? And I said yes. So it's 7 pi over 6. Now the reason I like that is because 7 pi over 6 is here. And if you multiply back out, wouldn't you get this? And the answer is yes. So sine of this. Okay, so what goes in here is 7 pi over 6. Now I had some of you all get real creative with 7 pi over 6 and try to build a triangle out of it. Don't do that. 7 pi over 6 is right here. And the sine, or the cosine rather, is negative square root of 2 over 2. This is sine. Cosine, sine. There's my 7 pi over 6. Cosine, sine. Negative root 3 over 2. So this becomes 1 minus negative root 3 over 2 all over 2. Of course, this becomes a plus. Okay, we turn that into a plus. And we make this 2 over 2. I want to do this because I got to keep my limits on how much space I have. I'm going to go down here. Equals 2 plus the root of 3 all over 2 all over 2. Now at this point you can either inverse and multiply if you like that, or you can multiply by the big 2 over 2 so that it cancels this one, and this one's on the bottom becomes 4. If you want to multiply by a half, 1 times anything is itself. You guys, when this number was anything other than 1, didn't multiply through by both pieces, just saying. This is gone because I switched it to here, so that left me 2 plus the root of 3 all over 4, which is square root 2 plus root of 3 all over the root of 4. Final answer, 2 plus the root of 3 all over 2. And it was positive to begin with, so I don't have to keep my negative. Half angle. I'm going to do this one right this time. So we do cosine, and this is going to be negative because we found out it was in the second quadrant. Negative big root 1 minus, or 1 plus, excuse me, because it's cosine, of something all over 2. Well, I'm going to take half, and what I would take half of is 5 pi over 4. You cut that bottom number in half, because if we multiply these, we're back to the 8 again. Okay? So it's cosine of this. So this is 5 pi over 4 equals negative root, and this is what's 5 pi over 4. 5 pi over 4 is here, negative root 2 over 2. 1 plus negative root 2 over 2 all over 2. All right, this becomes 2 over 2. So I'm left with negative root 2 minus the root of 2. I had to look and see what I had. All over 2. And I'm going to take times a half. So I get negative root 2 over root 4. So 2 minus the root of 2 over the root of 4, which is negative 2 minus the root of 2 all over 2. Final answer. All right, sum and difference with tangent. So if I look at the sum and difference with tangent, tangent looks like this, okay? So copy down your problem. I am doing addition. So when I do this addition, I will tell you, these are addable. So here, you're like, addable, what's that? I'm going to multiply by 2 over 2. So this is technically tangent of pi over 6 plus 2 pi over 6, which is 3 pi over 6, which reduces to pi over 2. My tangent of pi over 2 is undefined. It's 1 sine over cosine. It's undefined. So let's see what happens with sum and difference. Okay? So if we're doing sum and difference for this one, we're going to end up with its addition. So we have tangent. I'm going to spread this out. Tangent of pi over 6 plus tangent of pi over 3 divided by 1 minus tangent pi over 6 times tangent pi over 3. Well, I'm going to fill all these in. So tangent of pi over 6, I've got to go back and know what my tangent of pi over 3 and pi over 6 are. The tangent here is equal to square root 3 over 3. Now, I'm not going to take time to do it right now, but it's sine divided by cosine. This ends up being square root tangent equals square root 3 over 3. Tangent here on this one, we'll be happy to know, is 1. Tangent here on this one is the square root of 3. So that means the tangent pi over 3's, this becomes the root of 3. And this is 3 over root 3 over 1 minus, whoops, root 3 over 3 times root of 3. Okay, that looks scary. But if you take on just the denominator, this root 3 times root 3 is 3. So you get 1 minus 3 over 3, which is 1 minus 1, which is 0. So I have got something beautiful over 0, which is undefined. Or something ugly. I don't even have to know what this ugly is. Unless you just really want to know, you can make it 3 over 3. So I get 4 root 3 over 3 divided by 0. It's still undefined, guys. It doesn't matter. I'm done. So it made sense that tangent of pi over 2 is undefined, and now I showed you when we do an addition why it worked out that way. Now I have 2 more problems to do that are pretty simple, and I know this is probably getting long, trying not to keep it too long, but what you're supposed to do on these two should be really easy for you. You have sine cosine and cosine sine. Which one of these is it following? Well, I hope you've picked out that it's following the sine, okay? So if it's following sine and it's doing addition, it's the same as sine is 130 plus 50, because that's the pattern that it's following with the plus sign right here, all right? So that means it's sine of 180 and sine of 180, sine is 0. Over here you have cosine, cosine, sine, sine, so it's a cosine. And I have a plus sign, but on this paper with a plus sign in the middle of cosines, with a plus sign, it refers back to a sign, to a minus sign. When it's plus, it goes, when you condense back, it's minus. So this is 140 minus 20. 140 minus 20 is cosine of 120. And cosine of 120 is right back to negative 1/2. And I'm done. Okay, so I'm going to stop and show you the bottom on the next one.